Hi. So the topic, the course name is Basic Electronics Engineering, and I hope that all of you know about this particular subject is very much essential for the engineering course. And the course code is basically 201 and 101. Sometimes it's study in the first year, and sometimes it's study in the first in the first semester, and sometimes it's study in the second semester. So for that reason, that's the contact, that is the 3, and the award is the 36, and credit is the 3. So these are very important. As an engineering student, you have to know about these things. That's why I'm explaining these things. I know that sometimes you are starting your study, and you don't think about this particular matter, that how much need to study and all those things. This is very important for you. So for that reasons, I'm just explaining and elaborating these things, that what is the course name, what is the course code, and all those things. Now I go for the next. The prerequisite means that what is the actual requirement for the study of this particular subject. What is the actual requirement to study of this particular subject? That means that a basic course in the electronics and communications engineering process, from the fundamental of the electricity, direct current, DC device and circuit, series and parallel circuit of the study, and of course the Ohm's law and the Kirchhoff's law, KVL, KCLs are needed to know, because these are the very important. That is the how the current flow, and what is DC, what is the AC, what is the basic circuit. All these things is very much essential. That is the concept of the prerequisite of this. In case of basic electronics, if you concentrate on that this course is totally relate for different kinds of subject. Different kinds of subject means different kinds of uh, different kinds of different engineering that can be supported. If you go for any kinds of thing that is related with the electronics, you should know about the basic electronics, even civil engineering, mechanical engineering, and also the metallurgy and all those things. The basic electronics is very much necessity. uh, and as this particular course is conducted specifically from the electronics and communications engineering department, or electronics and instrumentations engineering department, so for that point of view it is a very important. But if you don't have any idea of the electron, if you don't have any idea of the electricity, direct current, and AC current, and all those things, you can suffer. So for that reasons, to understand all these things, this is very much mandatory, this particular prerequisite. This prerequisite is very mandatory for you. Okay, so there is all these things you have to study first. You have to know about all this, and then we can jump for the course. Next, this is the outcome. Everything have some outcome. Engineering course at present, now the Washington Accord, it is conducted some as per the Washington Accord. There is some course objective, course outcome, and all those things are there. So these are the CO1, CO2, CO3, and CO4 are there. CO1, CO1, CO2, CO3, and CO4 is there. So is here all these things are that's the first step is the study of the PN junctions, diode and ideal diode models, and the circuit analysis, applications of the diode and special diodes. Learn how to operational amplifier and modeled and operation amplifier model and analyze to the design of op-amp circuit, and performs the operations such as integrations, differentiations, electron signal. This is the course outcome of the second outcome of this course, which is very important. Now another the course outcome 3 is the subject study the concept of the both positive and negative feedback. It's a very important. That's a feedback term. This is very important. That's course objective, negative feedback, and the positive feedback electronic circuit. There is a feedback concept is there, which we can understand from there. Another things is that the development develop the capability to analyze the design simple circuit of contain the non-linear elements such as the transistors using the concept of the load line, operating points, and incremental analysis. So these are four things: 1, 2, 3, and 4. These four are the course outcome, and we definitely get some outcome from here. Now next go for another, that is the module 1. There is some modules, and all the module I'm just elaborating for your study. The first module is that the basic semiconductor, conductors and insulators and the semiconductor. So there is, you show the basic semiconductor, conductor and insulator. First we study about these things, and then after then the crystal structure, Fermi direct functions, Fermi level, EK diagram, which is very very important for you, energy band diagram, and the valence band, conductions band, and band gap, intrinsic and extrinsic, p type, n type types, concept of the semiconductor, and the positions of the Fermi level. There is a concept of the Fermi level, how much the system is working, how much the electron is stable, and energy about related to the energy and electron. There is a concept of the Fermi level is which is very very important. And also the intrinsic and extrinsic semiconductor, and the draft and diffusions current, which is also very important. The expressions of only not the number of driven and mass actions law, charge neutrality, and the semiconductor essential. And there is also the numerical problem, which is very very important in the engineering course, and the Fermi level related to the conductivity and mass action law and drift and diffusions current. So these are very very important for the module 1, for the module 1 positions. And next we go for the module 2. Here it is very interesting, very 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 interesting, that in case of PN junctions, the diode and its applications of the PN junction. PN junctions, how the PN junction is coming, P type, N type. Is there any possibility to P and N type is just junction and then automatically PN junctions is created? No, that's not. So how the PN junctions is developed, and what is the reason behind this PN junction, and all those things is very very important. The energy band diagram of the PN junctions at equilibrium, and the barrier energy, built-in potential at the PN junction, energy band diagram of the current through the PN junctions at the forward and reverse bias, which is very very important. How a diode is working in the forward bias and the reverse bias characteristics, that is very very important. And also the VI characteristics of the current expression of the diode, and the temperatures depends on the VI characteristics. So VI characteristics, voltage and current characteristics, how the voltage and currents are relate with that with this particular things, that is also very very important. After then I go for the another very important things, that is PN junctions breakdown conditions, and avalanche and Zener breakdown conditions, which is in the reverse bias conditions. That things is happen, we can study about that. The temperature dependency of the VI characteristics of the diode, how the temperature effect in the VI characteristics, that things, the early concept, early effect is also there. So these are the things are very very important for this. And then the after the engineer doubt, there is another, the doubt half wave rectifications. What is actually the concept of the rectifications, how we can convert AC signal to the DC signal? This is very very important in this particular portions, and also the full wave rectifier, half wave rectifier. There is several kinds of center tap concept of the rectifier. There is a rectifier concept of the bridge rectifier concept. So half wave, full wave, different kinds of rectifications we can study on that. And after then some characteristics, that is IDC, that means that is the current of DC, IRMS, that is root mean square concept. What is actually the root mean square concept, that is also we can study. VDC, that is the voltage DC and the voltage RMS, and ripple factor without filter, efficiency, peak inverse voltage, transformer utilization factor, TUF, PIV, which is also very very important for you. The reductions of the AC ripple using the filter circuit, quantitative analysis, which is very very important. Design of the diode clipper and clamper, which is also very very important circuit, and explanations with the example of the applications of the Zener down and regulation circuit, numericals problems are there. So these are the module 2. These are the module 2, and we go for next module. So yes, module 3. The module 3 is the bipolar junction transistor BJT, which is very very important for presently, that the bipolar junction transistor, the transistors, how the transistors is work. This is one of the subject you can get the basic concept of the transistor, which is very much essential for the several department, not only the electronics and communication engineering department or EIE department. It is very much essential for the electrical, mechanical, because in the mechanical there is a mechatronics subject, and maximum mechanical things is drives, and all those things subject is also related, and how the sensor concept is coming, and how the PN junctions, PNP or NPN transistors is working, how the switch concept is coming, that things you can clear from here, because this is the basic of the IC. When you are using the IC in future, so for that reason the basic concept of the bipolar junction transistors is very much essential for them. So these are very very important. So in that case, the fundamental of NPN and PNP transistors, most of the case the students cannot able to draw properly the circuit, which is very very important for to understand how to draw the circuit and all those things, the transistors and energy band diagram, also the current conductions mechanism, CE, configurations, common emitter, common base, common collector configurations of transistor, static characteristics of CB and CCB and CC mode, the static characteristics, which is very very important, and the junction biasing conditions for the active and saturations and cutoff mode current, and also there is a current amplifications factor or current gain and the early effect, that is alpha beta gamma, and the relations among the alpha beta gamma, which is very very important in this particular module, module 3, and this early effect and biasing, and biasing stability, biasing current, fixed bias, voltage drive, divider bias, collector bias, and DC load line and quiescent point, calculations of the stability factor for the different biasing circuit, and BJT as an amplifier, as a switch. It is also very important, the BJT as a switch, that to study about the BJT as a switch, the graphical analysis and the numerical problem. Basically in the industry, to enter in the industry as a engineer, and specifically for the electronics and communication engineering department and other, so this is very very important to know about the BJT, the basic concept of the BJT. In future, when you are entering in some gate level questions or the VEL question or ISRO question, there must be some questions from the transistors, there should be some questions from the transistor. So this is a very important chapter for you to understand the module 3, the chapter that is the bipolar junction transistors. If you can study about these things, you definitely in future get some question in future in your interview mode, and also in case of the government sector or anywhere. Okay, so this is a very important, that is the module 3. So then I go for the module 4, that is a field effect transistor. This is some things different from the BJT, and some advanced versions from the BJT, that how the field effect transistors concept is introduced from the BJT, that things is represent, this is the voltage control device, and how this is voltage control device is working, the concept of field effect, what is the concept of the field effect or voltage effect, we can understand here, channel width modulations, classifications, and FET, JFET, and MOSFET operating principle of the JFET, and drain and transfer characteristic, which is very very important, the drain and transfer characteristics of this. So JFET and N channel and P channel JFET, CS, CG, CD configurations, relations between the JFET parameters. There is a relation, that is transconductance and drain current and all those things. These relations are very very important. We will study about that's the relations, that FET as an amplifier, and as a switch, graphical analysis of E MOSFET, that is enhancement type of MOSFET, that is the P channel and N channel, and D MOSFET, that is a depletion type of MOSFET, that is, and one thing that is the form JFET, how the MOSFET concept is coming, why it is the metal oxide semiconductor field effect transistors is necessary, then the JFET, that things is necessary, and then after then E MOSFET and D MOSFET completions and the numerical problem related to this, and very very important. So these particular things are very very important. This particular module is very very important, that is a field effect transistors. Now go for the another that is very important, that is a feedback and operational amplifier. This is a one of the module. From here, if you can gather your knowledge, from here if you can gather your knowledge in future, if you go for any government sector in gate level examinations, in case of ISRO, in case of any that is veil, and any in IES, there is something you can get common from the feedback and this operational amplifier. This is very very important. And in this particular operational amplifier concept, that is very much essential, that how the op-amp is working, what is the actual op-amp, how the op-amp concept is coming. Basically this is the first introductions of the IC. We have to know about the IC from here. This is the concept of the IC 741. And first you show there is you show the concept of the feedback and feedback, that is a concept with the block diagram, and that is a concept with the block diagram, positive and negative feedback concept. Gain with the feedback topologies, different kinds of topologies, that is four types of topologies, that is voltage series, voltage shunt, current series, current shunt. So effect of the feedback on the input and output impedance, distortions, concept of the oscillations and the background Barkhausen's criterion, operational amplifier, electrical equivalent circuit, which is very very important. Equivalent circuit which is very very important. Equivalent circuit which is very very important. So ideal characteristics of op amp, non-ideal, that means the real characteristics of op amp, and also the offset voltage, offset null and offset current, bias current, the slew rate, that is the CMRR, common mode rejection ratio, and the bandwidth, which is very very important. For you can get the compact concept of the IC from here. The configurations of the inverting and non-inverting amplifications using the operational amplifier, which is very very important. The closed loop and the voltage gain and inverting and non-inverting amplifier concept, and the concept of the virtual ground. It is a very important, the virtual ground concept. The applications of op-amp, yes, we are the engineers, we have to know about the applications of op-amp, and that is working as a summer, that means adder, differential amplifier, also the voltage follower, the bias differentiator integrator, basic differentiator and integrator, problem of the characteristics of the op-amp and the CMRR, and the slew rate, amplifier applications, and the discuss any other relevant problem related to the topic, and discuss are assigned. So these are the compact things which is very very important for the module 5. These are the compact things which is very very important for the operational amplifier. You have to study operational amplifier properly, then you can gather the idea about that basic electronics. That's this particular IC. This is the first introductions of the IC of the electronics and communication engineering department and other department also. So these are very very important. That is the IC, to introductions IC by the operational amplifier. This is the last module. And this is the last module is the cathode ray oscilloscope, CRO. And as an engineer, as an electronics engineer, and as an engineer who will working in the future, that is the equipment, that is a measuring equipment. And anywhere if you can go for any kinds of signal related things, any kinds of measurement of the voltage, and any kinds of things of measurement of current and all those things, that for voltage and voltage amplifications, frequency, and to know about the signal and all those things, these portions, that is the cathode ray oscilloscope, which is very very important for you. which is very important, which is very important, because that how we can operate the operate the CRO, cathode ray oscilloscope. And in case of cathode ray oscilloscope, how we can measure the frequency and phase, how we can measure the voltage, how we can measure the things, and inside of the CRO what are the things are there, how it is working, and all those things are here it is. That's why this is the cathode ray oscilloscope, which is very important for you. So understand about all these things. This is very essential for you to understand. And that's all about this basic electronics. Now I want to say that this particular basic electronics, this particular subject, what is the actual theme of this subject, that what is the need of this particular subject for the others department. Suppose if you ask me this question, that why civil department is study this particular subject basic. Suppose if you in future civil engineer students are working in a particular company, and where they can go for one project on the road, and in this particular road, one things is that some piezoelectric sensor based road piezoelectric sensor based road monitoring system, or camera based road monitoring system, piezoelectric road sensor based that is different kinds of project related to the electronics on the road or bridge. How much bridge is there is some equipment that can be measured, that the some sensors that can be measures that present conditions of the bridge and all those things. So for all that case, the electronics are necessary and mandatory. So if you are a civil engineer, and if you have the concept of this all those things, nominal concept, not the deep level concept, then you can justify the others engineers, you can very much easily cope up with the others engineers to work with that. At present now the engineering is a totally interdisciplinary engineering. So in case of this interdisciplinary engineering, there is no any barrier between the civil engineering and the electronics and communication engineering. There is no any barrier with the electrical engineering in the computer science engineering. There is no any barrier in the chemical engineering to the others engineering, mechanical engineering, and all those things. So these are all integrated, they are same, and there is a same things that to develop one product, all the concept is mandatory and necessary. Whatever the component concept is required, that should be studied. And by this basic electronics you can gather some knowledge about that, and then you can understand about these things, and through that you can very easily benefit it. You can give the benefit to everybody. So this is a very important for you to understand. That's why the basic electronics very much necessary. So that's all about this syllabus. That's all about this syllabus. I am elaborating all these things. These are the syllabus. And thank you very much. Thanks you.